Okay, so today we're going to talk about coterminal angles, and we're on lesson N1-3. So coterminal angles, as it says right here, are two angles in standard position that share a terminal side. So just to kind of go back, standard position means we start at the x-axis, so we would start here, and we're going around, right? This would be our terminal. So they're coterminal if they end at the same place. So 30 degrees ends here, and if I come around the other direction, right, then the angle that ends there. So it's just the idea that they're coterminal because like 390 means I went around 360 degrees plus an extra 30. Okay, so that's what we're showing here. And negative 330 degrees, we started at the and went around. Okay, but they all have the same terminal side. So that's why they're called coterminal. Okay. All right. So let's see if we can't get some other. Alright, so give two angles, one in a clockwise direction and the other in a counterclockwise direction, that are coterminal to 500 degrees. Okay, so right, we had 30 plus 360, 30 minus 360, so we're going to operate that same way. We're going to have 500 plus 360 and 500 minus 360. So 500 plus 360 is 860 degrees. 500 minus 360 is 140 degrees. Alright, pretty easy. Alright, so negative 60 to other coterminals, we'd add 360 degrees, and we could subtract 360 degrees. So we'll get 300 degrees and 420 degrees. Sorry, negative 420 degrees. Can't leave off our signs. Okay. All right, so what happens when we go over to radians? I know that was the question burning in your brains right now, right? Okay, so when we go over to radians, it's the same idea, except instead of 360, what's the radian equivalent of 360? Hope you remembered, it's 2 pi. Okay, so since 2 pi is equal to 360 degrees, right, we would say pi over 4 plus 2 pi, and we would do pi over 4 minus 2 pi. Okay, so pi over 4 plus 2 pi. Remember when you're adding fractions and things, right? This is how I would do it on my calculator. I would just take into my calculator and say 1/4 plus 2, and just put that enter on my calculator. Gives me 2 1/4, which is the same thing as 9/4. Okay, and that's probably what would come up on your calculator, so that would be 9/4 pi. Okay, and then pi over 4 minus 2 pi. In my calculator, I would put 1/4 minus 2. Right? And then 1/4 minus 2 is going to be negative 1 3/4, or in improper fractions, negative 1 3/4 is negative 7/4. Okay. Let's try another one. Negative 2 pi over 3. So negative 2 pi over 3 plus 2 pi, and negative 2 pi over 3 minus 2 pi. Okay, so again, it would be negative 2/3 plus 2, which is 1 1/3. Okay, and 1 1/3 is the same thing as 4/3. So that would be 4/3 pi. Okay. Negative 2/3 minus 2. Both negative, so we add them together, so that's negative 2 2/3. which is the same thing. Let's see, if that's negative 2 2/3, it's going to be 6, 7, 8/3. Negative 8 pi over 3. Whoops, that didn't show up. Let me bring it up. Negative 8 pi over 3. All right, let's move on to another idea. Okay, it says the reference angle is the smallest positive acute angle determined by the x-axis and the terminal side of theta. Okay, so what we're saying there is, even though we have all these angles that are coterminal, what the reference angle is the absolute smallest version of that. Okay, so back to the very beginning where we had 30, 360, negative 330, all those. 30 would be the reference angle because it's terminal side, right? The x-axis and then the terminal side. So we'd be starting here at the x-axis. Okay, so what we're saying is we'd start at the x-axis right here, and when we hit this is our reference angle, and we use the alpha symbol. Looks kind of like a little fish. All right, to denote that that's going to be our reference angle. Okay, so draw each angle theta in standard position, find the reference angle alpha, label theta and alpha. Okay, so we take our handy dandy axes, 150 degrees. Well, there's 90, so we're starting here at the x-axis. We go 90 degrees, 180 would be the next line, so 150's about there. Okay, so that's going to be our theta. Okay, now from the x axis, here's the closest part of the x-axis, so this here is going to be our alpha. It's from the x-axis to the angle, and it would be measured as a positive angle. Okay, so 150 degrees, right? So this distance here would be 30, because back from 180 is going to give us that 30 degrees as a reference angle. Okay, let's try another one. So we have 315 degrees, so we start at the x-axis, we come around, there's 270, this is 360 up here, so we're going to be probably coming around in here, so let's that's going to be 315 degrees, and that's our theta. Okay, so the reference angle then is from the x-axis to the, okay, so there's our alpha, and here we're going to, since we're coming here to 315, the easiest way to find that number is to say 360 minus 315, which is 45 degrees. So I went a little high on the 315, but you know, forgive me. Okay. All right, so that's how we do it with degrees. Let's take a look at how it would work out with radians. Oops, too far. So we have 4 pi over 3 is our theta. Okay, so when we're talking about thirds, that's saying this top section here would be divided into thirds. So I'm going to just kind of do that. So there's 1, about, right, 2, 3. So each of these sections is about a third. Okay, that's what we're going with. So if I've got 3 at the top, 4 thirds, right, it's going to be about there. Okay, so if I start here and come around, that's about 4/3 pi, or 4 pi over 3. And that's going to be our theta angle. Okay, so where's the x-axis? Right here. Okay, so we're coming down to that terminal side. Okay, so at 4 pi over 3, this is pi, so we want what's the difference between 4 pi over 3 and pi. So 4 pi over 3 minus pi is going to be our alpha. Okay, so remember that pi would be a whole number, so we could make it 3 over 3. So 4 take away 3 is 1, so this would be 1 pi over 3 would be our alpha. Alright, so pi over 6, again, so we're taking pi, which is the top half of our quadrants here, and we're going to divide it into 6 parts. So there'd be 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. So we're going to go up one of those. So that's about here. Okay. So there's our theta, pi over 6. And hopefully you can see if we're starting here at 0 and we're going to here from the x-axis, alpha is also pi over 6. Alrighty, so let's take a look at this next section, and it says determine how to find the reference angle in each quadrant. Okay, so since the reference angle is going to be the distance from the x-axis, in the first quadrant, that alpha is the same thing as theta. Okay, alright, so we're in the second quadrant, we're coming back from pi. So alpha would be pi minus our theta. Okay. Here we're going from pi to the angle. Okay. So it's going to be theta minus pi equals alpha. And then finally in the fourth quadrant we're coming from the x-axis here, when this is 2 pi, right? So this alpha will be 2 pi minus theta. Okay? And then we can replace 2 pi with 180 degrees. So when we're looking at degrees, it's going to be 180 minus theta. This would be theta minus 180. And then over here we would have 360 minus theta would equal